Okay, I think it's a good time to start today's webinar. So first, welcome everyone, and we already have like 80 people in the meeting, and it's my great pleasure to introduce today's speaker. First of all, I'm Dr. Xingyan Huang from Hong Kong Polytechnic University. So this webinar is co-organized by the Building Service Engineering Department, as well as SFPE Hong Kong Student Chapter. And today's speaker, Dr. Long Shi, is one of my long-term friend. So we know each other since our PhD studies. He's currently a senior lecturer in the RMIT University in Australia. He obtained his PhD from National University of Singapore. And Dr. Shi's research has been focusing on both fire engineering as well as new energy technology related to the building. He has so far been published more than 80 peer-reviewed journal papers, including many high-impact factor journals. And today he will share a very new topic. It's very interesting to me, is using the solar chimney to build for the building fire safety. This is a very new concept. And so let's welcome Dr. Shi, and I will hand my microphone to you.
Thank you, Professor Huang. I share my screen. Can you see my screen?
Yes, looks good.
Can you hear me?
Yes, loud and clear.
Okay, great. First, I would like to thank Professor Huang for his invitation for me to give this presentation or to share my recent research progress on solar chimney. As Professor Huang mentioned, my research background is much based on fire safety. Now, recently, I just want to combine my fire safety and knowledge with a renewable energy system called solar chimney. I believe some of you already heard about solar chimney. So for today's presentation, I will give you my research progress in the last 5 years. Also, it's my honor here to share with you my recent progress. So my name is Long Shi. I'm a senior lecturer at RMIT University. So today's presentation is about using solar chimney for building fire safety. So this is the main content of today's presentation. So I will give you a little bit of introduction about solar chimney and why I want to use solar chimney for both fire safety and energy saving. And then I will give you an introduction about the real application in Australia. So one of the applications, then the conclusion. So the reason why I want to use the solar chimney to in building is because this is now, as everyone know, that the energy is one of the biggest energy. The mechanical ventilation system is one of the biggest energy consumer in the whole building. So usually for the heating and cooling, which is called space conditioning, can take almost 40% of all the energy in the whole building. So this is one of the biggest energy consumer. As you know, in Australia, it is very Australian government is very looking high on the energy saving or energy efficiency. So as an example, Australia Sustainable Building Environment Council has announced that if we save and improve the energy efficiency in building, which can offer a total 26.7 billion saving Australian dollars for Australia between now and 2050. And also Melbourne City, this is the city I'm living now, so has initiated a 1,200 building program for the related building energy retrofitting. So these are two examples. As everyone know that there was a big fire disaster in London, so happened in 2017. So this has caused 71 deaths. So which is one of the deadliest fire in the UK uh, since the 1988. So or since the Second World War. So this is a big disaster. So that's reason we have so many people doing research on fire safety. As you know, the fire safety in Australia is also very important as well. As you know, that the fire caused about 42.2 deaths per year. And also you can see from this one that there's a huge jump about fire deaths in 2009. This is because of Black Saturday due to the bushfire events. So you can see the total cost of fire was estimated at 12 billion Australia dollars, or 1.3 GDP of the whole Australia. And as you may know that one of the most important factor about fire, it is about the smoke exhaustion. Because you can see from these figures that more than 50% or 60% of the fire casualties are because due to the fire inhalation because of the smoke. Okay, you can see from this. And the second part I want to introduce you about the solar chimney. Probably not all the people are here about solar chimney. Solar chimney is actually a very simple structure in our building. You can see this is a solar chimney. You can see the solar chimney is very simple. It includes, this is a glazing wall, and this is a concrete wall or brick wall. And under solar radiation, we can see that the air inside the chimney cavity can be heated up. So the temperature of the air inside this chimney cavity can be higher than the outside, then will cause the thermal buoyancy. So the air inside this chimney cavity can go up more, so or go exhaust to the outside. This will lead into the circulation or airflow from the outside through the window to indoor and to the chimney cavity, then to outdoor. So this is a pathway here. So you can see for this one, it is can be used during summer, that can take the heat inside the building, that can cool in the whole building. So for this one is the same. It is called a roof solar chimney. Roof solar chimney is share the same structure with the wall solar chimney, include the glazing wall and also a concrete wall, or called the absorption wall. So the same function, you can see there's inlet here, outlet here. So you can see for this one can lead into a pathway, air pathway here, like this way. So this is for the fundamental of solar chimney. And so this slide just shows the two different models for solar chimney. For this one, as I mentioned, it is for the cooling purpose during summer. You can see for this one, we can have the inlet here, then the cold, this can be used adopted during the winter. So the cold air can enter the chimney cavity, then enter the building. So this heated air can achieve the heating purpose of the whole building. So these are the two models for solar chimney. How solar chimney works, you can see the air. You can see the air can enter the building from the window, then enter to the chimney cavity through the inlet. So this can also be used to the fire safety, because the smoke exhaustion share the same principle, which is the thermal buoyancy, like the natural ventilation. Okay, so that's the reason why I use the solar chimney for both energy and life saving from fire. So these are the typical types for the solar chimney. Can be combined with wall, roof, window, roof, or both. So even though solar chimney is very simple structure, it has a large number of influencing factors. You can see it can be, the influencing factor can be categorized into 4 types. The first one is chimney configuration. Chimney configuration can be, you can see this is a chimney, the height, the cavity gap. Cavity gap, it is a gap between the glazing wall and this absorption wall. And inlet area or outlet area, installation condition, and so on. And also you can see materials usage is one of the most important factor for the solar chimney performance. And also this can be affected by the environment as well, such as solar radiation, external wind, or other climate conditions like ambient temperature or relative humidity. Okay. So for part 3, I want to introduce you the multi-function solar chimney. Multi-function solar chimney is the, I call it multi-function solar chimney. This is because this solar chimney can be used for both energy saving and fire safety. Okay, energy saving is through the air movement, so it can take out the heat, or during summer and input the heated air during winter to save energy from the air conditioning system. And for fire safety as well, so this can exhaust the fire, exhaust the smoke to outside, that can largely reduce the fire risk inside the building. As I mentioned, the smoke from fire is one of the most important factors to determine the fire safety of a building. So first thing we need to do, we have done it, is to confirm the viability of solar chimney to be applied to the fire safety. So you can see this is the test model for the test. So this is reduced scale 1:3 ratio, reduced scale test platform. This is a cross section. You can see, because to achieve the stable environment, we use the laboratory test. So which means that the whole test has been taken in the indoor environment. So we use artificial lights to simulate this solar radiation. We use thermocouple to measure temperature, and so on. Okay, so we have the pool fire, liquid pool fire inside the room. Okay, and so for the test procedure, because we want to use solar chimney for both natural ventilation and also smoke exhaustion as well. So the whole test can be divided into 2 steps. The first one, it is for the before the ignition of the liquid fuel or pool fire. So this is called the lateral ventilation part. After ignition of the pool fire, the solar chimney can be at the smoke exhaustion model that can exhaust the smoke to the outside environment. So these are one of the test results about inlet height. So for inlet height, we can see it is the height between the inlet, air inlet, and the bottom, which is floor. So for this red dot shows the influence of inlet height to the volumetric flow of rate of the smoke. Okay, and for this one, it is for the air before the ignition of liquid fire. So we can see the black points are representing the natural ventilation part, and for this red part represent the fire safety part. So we can see that once the air inlet is located at the middle height of the wall, it can achieve the best performance of both fire safety and also the natural ventilation. Okay, for cavity gap as well. So cavity gap, it is a distant horizontal distance between the glazing wall and the absorption wall, we can see there is it is not like the bigger cavity gap will result in better performance. So once the cavity gap go over a value like 12.5 centimeters, then the volumetric rate goes down. So these are some of the trends. And also for this one shows solar radiation. The solar radiation can have quite obvious impact on the overall performance of natural ventilation, but it has limited impact on the smoke exhaustion. This is very good news because which means that solar chimney can be adopted during night, even without solar radiation. And also this is for the fire size. We can see for the fire size that smoke exhaustion rate can go up under a big fire, okay? And these are the, we also have developed an empirical model predicts the volumetric flow through this chimney cavity as well. So because of time limit, I'm not going to details for this. If you are interested in this, you can read my papers. And the second part is about the interaction between window and the area net. This is one of the most important factors in the optimization design in practical application. This is because, as mentioned, and as we get from the experiments, we can see that once the area net it is located in the middle of this wall, it achieved the best performance for both energy saving and fire safety. Okay, so then we were thinking about what could be the best combination between the area net height and window height during practical applications. So that's the purpose of this study. So this study is much based on numerical methodology, and we use FDS to construct the CFD model and to simulate the airflow rate through the chimney cavity under both natural ventilation model or fire safety model. We have tested a lot of influence factors, but we see that we also found a similar result that once, this one shows the result once the area net and the window are both located at the middle of the wall, it can achieve the best performance for both fire safety and energy saving. And we also developed an empirical model to predict this. The reason why we want to develop the empirical model is to simplify the practical application, because during practical application, if you do some safety modeling, it is very time consuming. And the third part of my study is about the solar tunnel. So I have applied the solar chimney to building. So the solar chimney can be applied to the tunnel because of some of the subway tunnel has very good condition or environment to adopt solar chimney, because some of the subway, it is very shallow in the underground. So it is quite easy to build the related solar chimneys through the in the tunnel. The existing tunnel system, natural ventilation system, use this like this mechanical ventilation system. This system has one obvious drawback, because it cannot exhaust the smoke to outside the tunnel, but it can just move the smoke from one end to another to postpone the safety egress time. So that's the function of the existing mechanical ventilation system. So why we cannot use solar chimney for for our tunnel. This is the model we constructed based on FBS. We installed the solar chimney on the top of the tunnel. So we investigated the influence of the solar chimney on the smoke velocity and also the smoke exhaustion rate through the solar chimney. We can see this is a very interesting outputs. So the x-axis is the distance along the tunnel, and the y-axis it is the average smoke velocity. We can see this is the points with the solar chimney. Once the smoke pass by the solar chimney, we can see the velocity of the smoke can be largely decreased. The decreasing rate is much dependent on the solar chimney configuration, like the solar chimney height or area net and so on. So we also do some theoretical models to do that, because for the traditional model, consider well-mixed smoke on the top inside the solar chimney. So this part, it is for on top of the tunnel. It is for this part only. So to simplify the analysis, so in our theoretical model, we use the more complicated situation like vertical linear temperature distribution. This is a reasonable extension because this is a glazing wall. Once under the solar radiation, the air inside the chimney can be heated up gradually, which means that the air at the top, the temperature of air at the top will be higher than the air at the bottom. So which means that it shows a vertical linear temperature distribution inside the solar chimney. And also the horizontal parabolic temperature distribution is also reasonable because the heating up process of the air inside the solar chimney is because it is much based on the thermal convection. So, which means that some of the air in the middle will be rarely heated up. So the temperature will be much lower compared to the temperature near the wall. Okay, so when we consider both vertical linear or horizontal parabolic, so we will consider a temperature distribution like this. Okay, so we also developed empirical model to predict this. We found that if we consider the both vertical linear and horizontal parabolic temperature distribution, the predicted air rate could be reduced by almost 37%, which means that the existing model are overestimate the airflow rate through the chimney cavity. So this is one of the contributions from this paper. And next part I'm going to introduce you about the real application. So actually we have three applications. Due to the time limit, I just will introduce one. So this one application is in Melbourne. It's very close to RMIT University, about 20 kilometers in Kingston City Council. This is a two-story building for the city council. So I have an introduction video for this. So this is the building. This part is solar chimney part. This part, this are the outlets. See, these are the FDS outputs. So this research is collaborated with the SFPE Council. So I also have another introduction video about the mechanism of solar chimney. I just want to show you this as well. Probably need to wait a while. So this is a cartoon made by one of my master students. So this is a 2D model. So the solar chimney can be also adopted for fire safety. This is actually for this one. And so for the solar chimney design, so the city council invited me to design a solar chimney for this building. So consider the location of the Melbourne, and also to maximize the solar radiation, I adopt this location for solar chimney because it is directly facing the sun, can absorb as much solar radiation as possible. And also, the second reason is because this one connected to a big social room. This is the biggest room of this building, so which means that the solar chimney can connect it to the biggest room, can increase the efficiency of solar chimney. So this is the model we built based on FDS, and we conceive the different numerical scenarios and different parameters for the optimization design. And so this is the situation outputs of FDS under the natural ventilation. Natural ventilation means that there's no fire inside, just the exhaust air to the chimney cavity, then outside to achieve a cooling model or heating model. So for the fire safety as well, so you can exhaust the smoke to the outside. So it is very important. You can see that the location of the solar chimney can produce significant impact of the smoke exhaustion performance. And we invest the different parts. We can see the first one is chimney gap. Chimney gap, it is the gap between the vertical distance between the glazing wall and the absorption wall. So we can see the maximum one, it is at the 1.2 meters. Even though the increased chimney gap will not further affect the overall performance, but consider of the materials. So 1.2 meters gap, it is can achieve the best performance. For the fire safety as well, 1.2 meters. And this is for chimney cavity height. We can see that the maximum height happened at the maximum height we considered during the numerical study, so which is 3 meters. If we keep increasing the cavity height, like 5 meters or 6 meters, the performance could be further enhanced for both natural ventilation and the small fire safety as well. So these are the two types of air supply method. It is from the bottom door, one is from the top vent. So according to the simulation, we found that the bottom door, it is much suitable for the air supply. And this is a location for the solar chimney. The location of solar chimney is represent how much part below the ceiling. So if we put too much below ceiling, that will affect the smoke exhaustion. But if we put too much on the top, it may affect the natural ventilation performance, further affect the energy saving. So this is about solar radiation. It is pretty much the same, following the same trend as we obtained from our previous study. So you can see that solar radiation has always reaches influence on the energy saving performance. I forgot to let you know that the energy saving performance here, it is reflected by the airflow rate through the chimney cavity. Okay, this is a solar radiation. We can see it has limited impact on the smoke exhaustion rate. And this one, it is a little complicated. It pretty much shows the consistency of the design of one solar chimney in terms of the energy saving or fire safety. So because the positive line means that the one design will enhance the performance of both natural ventilation and the smoke exhaustion. It will not compromise one aspect. But for those, like this line shows the chimney cavity location, it shows negative slope, which means that if we design the solar chimney for fire safety, it will compromise the performance of energy saving. Okay, this is the only one we shows negative consistency. Okay, so these slides just show the performance in terms of fire safety. The left column shows the output of visibility, temperature, and the carbon monoxide concentration without solar chimney. And the right column shows the performance with solar chimney. You can see that solar chimney can naturally enhance the fire safety of the whole building. So to describe it quantitatively, we can see in terms of the fire safety, it can extend at least 6.52 times of the available safety egress time for occupants for fire emergency evacuation, which means if the available safety egress time for the existing building without solar chimney is 100 seconds. If we install the solar chimney, the available safety egress time could be extended to 652 seconds. That will largely enhance the fire safety of this building. So this is the final design of this building, of solar chimney. This is a real building. So this building has been, the construction of this building has been completed in this January. February. So it is already done. And so for this solar chimney performance, in terms, I just forgot to mention, in terms of the natural ventilation, we can produce 7.42 air change per hour, which is almost fulfill almost all the standards, building standards in terms of natural ventilation. So this is quite good design based on solar chimney. For the fire safety side, it also can extend at least 6.52 times of the available safety egress time for occupants. So the last part is about the conclusion. We can see that solar chimney is quite simple structure, but it can produce quite efficient or quite good performance in terms of both energy saving and fire safety. So that's the reason why I adopt the solar chimney for both energy saving and life saving from fire. And also, in my current research, I'm now trying to expand the function of solar chimney for other parts. That's pretty much it. Thank you so much. So do you have any questions?
Thank you, Professor Shi. Let me check if there's any question in the chat room. And if any audience have questions, you can also put in the chat room. So far there is none, but I have a few. So when I was when you introduced the gap, you mentioned there is a magic number of 1.2 meter. So is there some special meaning for this 1.2 meter? It's just luck, or it's just it's universal for other buildings as well?
That's a very good question. So 1.2 meter, the maximum chimney gap, it is only applied to this building. So because of the building structure and the configuration. So I'm not sure this will apply to other buildings as well, but more research can be done regarding this. But for this building, it is 1.2 meters.
Okay. So maybe the building height and maybe some other parameter will change this optimal value.
Yeah, yes, of course.
And regarding the chimney effect, to my understanding, the building height is a big issue. Is one of the important factor. I think it also applies to the fire safety. Usually, if you have a larger atrium, the chimney effect will be strong. And similarly, if you have a large floor height, the smoke will be easier to extract it by natural ventilation. Is that true?
Yes, yes, of course. So for this building, for all the building, we are very positive that the higher the chimney cavity is, the better performance of the solar chimney could be. So during the practical application, it is recommended that the maximum chimney height can be adopted following the building standards. So which means that the maximum allowed chimney height can be adopted in the building. So for this building, we have City Council has a lot of communication with the local policy supplier that negotiate with the chimney height. That's the reason we adopt the solar chimney, which means no part of the solar chimney are above the ceiling. So the maximum, the height limit in Australia is pretty much 9 meters here, even though the higher the better.
I see one question from the chat room. One asked, when checking the efficiency of solar chimney, are the cases with and without glasses compared?
Can you repeat? Sorry.
So well, the glass make a big difference. And if the wall is just a regular wall, or if it's a glass wall, will it make a big difference?
Yes, the glass, the selection of the glazing wall and also the absorption wall is to maximum the absorption of the solar radiation and also the maximum the heat transfer, which is a convective heat transfer between the glazing wall and the absorption wall and air. So which means that the selection of the glazing wall is very important. For example, the higher transmissivity, the better, because it allowed more solar radiation penetration inside the chimney cavity. And also, we can adopt regular wall, like a bracket wall, inside of the solar chimney, but it is recommended to paint it black because that will enhance the absorption of the solar radiation. Sometimes we even use the phase change materials to maximum or extend the heating process, but that is quite expensive.
Hey, seems like if you're using the phase change material, you are reducing the solar heating effect. I'm not sure how the phase change material is applied.
So phase change materials, the critical part is about the phase change temperature. For example, during daytime when there is a solar radiation, the phase change material can absorb as much heat as possible. And then during night, it can release the heat after gradually from the phase change materials. That even during night, it can also achieve the heating or cooling purpose. So that's the advantage of adopting phase change materials.
That may also relate to one of the questions in the chat room. Someone asked if the design only suit for the building with daytime function.
Yes, also no. Yes means that if you don't want to adopt phase change materials, then it is pretty much for daytime usage. But if you want to adopt the phase change materials, can achieve the lighter time natural ventilation. And also, as following this presentation, we can see that solar chimney can exhaust the smoke. So which means that during night, the solar chimney can naturally enhance the fire safety of a building. So which means even though if you don't adopt any phase change materials, but solar chimney can also protect you from fire during night.
I think that's most of the questions. Some others are not very related.
Okay.
In fact, it seems like it can be used in L terminals, so L port terminals, because usually these terminals have many glass walls. Then maybe easier to enhance the chimney effect. But suddenly I realized it may not be working in Hong Kong because here it's too humid. It's not really about cooling in the summer. It's more about dehumidification because the air outside is also very hot and humid. But probably working very well in Australia with a Mediterranean climate.
In Hong Kong, I think this can be adopted as well. Even though the humidity is a very important part, and for solar chimney, because it can enhance natural ventilation, so it can remove those moisture content inside the building, which means the humidity of the building. So But for the real application, we need to test it. So.
Okay. Yeah, seems like there's no other questions. Okay, I think it's a really fruitful webinar today. And for everyone who joined this meeting, and we will email you a certificate afterward. And we will have another webinar this Friday related to the file in structure. So you're also welcome to join us. I think that's all for today. Let's thank Professor Shi again.
Thank you very much, Professor Huang. Thank you, everyone.
Thank you.
Thank you. See you. Bye-bye.